Okay, in this third video, we're going to continue with simplifying radicals, but we're going to do rational exponents. So a radical can look like the nth root of a to the m. And so what this translates to is the base a raised to the m divided by n power. So m divided by n. So the index of your radical becomes the denominator of your exponent. So this is a rational exponent because it's a fraction. And when I write here the double arrow, is that it means it goes both ways. So I can say, for example, the fifth root of 2 cubed will become 2 to the 3/5. Or I can say if I have, let's say, 7 to the 2/3, this will mean I can write it as a radical. And looking at it this way, notice that the denominator is the index of the radical. So this will be a cube root of 7 squared. And then I can simplify this a little more by saying the cube root of 49. And so we can simplify some expressions. For example, say I want to simplify the cube root of 8x squared over the square root of x. So this is something where you have a mixture of indices. So you have a cube root and then you have a square root. And so let's see. Well, 8 is a perfect cube, so I can't take that out of the cube root. So I will start with taking anything out of the radicals if I can. So the cube root of 8 is 2, right? Because 8 is equal to 2 cubed. So I can take the cube root of 8. So this will be 2 times the cube root of x squared over the square root of x. And at this point, it may seem like we're stuck. Okay, there's nothing I can do except that I can use those properties. This property that a radical can be converted to a base with an exponential power, with a rational exponent. So I'm going to say then that this is 2 times x to the, remember the index, the 3 becomes the denominator. So this will be x to the 2/3. And next was at the bottom, x to the, remember when there's nothing there, that means there is actually a 2, an invisible 2. So this will be 1 over 2. The index becomes the denominator. So there is an invisible 1 there. There are many invisible things here. And so now I'm dividing the same basis. So now is rule of exponents that when I divide the same basis, we subtract the exponents. So this will be x to the 2/3 minus 1/2. And now we can simplify that. So let's do it on the side over here. And I'm going to use it in a different color. So 2/3 minus 1/2. So I'm going to say side work. This is getting a common denominator, 3 and 2. The LCD is 6, so I'm going to multiply this one by 2 to make it a 6, and this one by 3, top and bottom. So I have 4 6s minus 3 6s. So now that the denominators are the same, I can just subtract the numerators. So I get 1 6. So going back over here, then my answer looks like it's going to be 2x to the 2/3 minus 1/2, which I just found it to be 1 6. Because the original problem was given to me in terms of radicals, I want to write it back as a radical. So this will be 2, and this will be, what will be the index? Which one is the index? The denominator. So this will be the 6th root of x. And this will be my final answer. And you'll encounter some more problems like that in your homework. And so when you have different radicals, different indices, don't think that you're stuck. Remember, oh, I can use that property that tells me that a radical can be written as a base and a rational exponent, a fractional exponent, and then you can use the other properties of radicals that we discussed in the part 1 of this section.